Welcome to part one of case study ex3, where we'll show how to apply key operators in RxJava's observable class. In particular, in part one of case study ex3, we'll show how many RxJava observable operators are used to create, multiply, and display big fraction objects asynchronously, even in the presence of errors. We'll also show how to apply various single operators as well. As usual, you can find all the source code we'll be walking through at the link at the bottom of the slide. We're now in the IntelliJ project for case study ex3. Let's start by taking a look at the ex3 class, which as usual defines the main entry point into the test program. We have three methods under test here. We'll look at the first two in this part one of the video, and then in part two, we'll look at the third method. Test fraction multiplications uses an asynchronous observable stream and a pool of threads to perform big fraction multiplications and additions. Test fraction exception uses an asynchronous observable stream and a pool of threads to showcase exception handling of big fraction objects. And as I mentioned before, we'll take a look at test fraction reduction multiplications in our next video. All three of these methods are registered with the async task barrier. And when we go ahead and call its run tasks method, it will run all those methods. They'll run in the background doing asynchronous processing, and the main thread of control will block using blocking get until all the processing is finished running asynchronously, at which point we print out the number of tests that completed successfully. Let's now go ahead over and take a look at Observable EX. As you can see here, it has a field called sRandom. That's a random number generator. It's used to generate big fractions. Let's take a look at big fraction multiplications first. As usual, we create a string buffer to hold the results we're going to display at the end. We then go ahead and make ourselves an array of big fractions. And as you can see here, we give those big fractions various values that are somewhat hard-coded, if you will, to be numerators with 1,000 and then denominators that are 30, 40, 20, and 10, respectively. We also make ourselves a little local variable consumer that we use to display the results when we're all done. As you can see, it's going to go ahead and append a message and then use the big fraction utils display method to turn the string buffer into a string and display it. Now let's take a look at the main stream that we have. As you can see, we use the observable from array factor method operator to convert the big fractions array into a stream of big fractions. And then we use the RxJava flat map concurrency idiom to multiply all these big fractions asynchronously in a thread pool. As you can see, we're going to call the multiply fraction helper method here. And multiply fraction, as you can see, takes in a big fraction and a scheduler. And it uses a single chain in order to first convert the big fraction into a single using the from callable factor method operator. It then subscribes the processing to run in the background scheduler that was passed as a parameter, which in this case is the computation scheduler, which is intended for CPU intensive processing. Then we have the map transforming operator, which applies a multiplication of this S big reduced fraction. We've seen this before. It basically is just a big fraction constant with large numerator and denominator. And then the final thing we do here is we convert the single to an observable. You'll see another variant later where we just start out by using observable from callable instead of single from callable. I'm just demonstrating you can do things either way. So this will go ahead and run all of those big fractions concurrently using the computation thread pool. When we're done, we log the big fractions just so we can see what the values are at this point. And then we apply the reduce combining operator. And if you recall, reduce will go ahead and take all the results that it gets in the stream and reduces them into a final reduced result, which in this case will be composed by adding up all the big fractions that are given to it in the stream. What it returns is a maybe, which is basically like a single, but it could be empty. And if all goes well, which it will in this case, we will use the maybes due on success operator to display the results. So it'll print them out. And then the last thing we do here is we call ignore element, which basically says send back a completable so that the async task barrier framework knows that we're done. Let's now go ahead and take a look at test fraction exceptions, which will show off another cool error handling feature that we've talked about in earlier parts of this lesson. As you can see, we make our string buffer as always, and then we go ahead and make ourselves a local variable, which we call error handler. And an error handler is a function which takes a throwable and a big fraction, and it appends what the error is, which is the throwable or the exception. It prints out the message associated with that particular throwable. And then it checks to see whether or not that throwable is indeed an instance of arithmetic exception? And if it is, it's just going to convert that value into a 0. If it's not an arithmetic exception, then we don't know what's going on. So we go ahead and we throw the throwable again. We rethrow it essentially. So down here, you can see that we have, let's just say rethrow exception, make it clear. So down here, we have the main bulk of the logic. The first thing we're going to do is we're going to make ourselves an integer array of denominators. And as you can see, one of the denominators in this array is the value 0. And you'll see how that is used to trigger an arithmetic exception in just a moment. We then use the from array factor method operator to convert that array of denominators into an observable stream. So we have a stream of integers. And now we're going to use RxJava's flat map concurrency idiom once again to reduce and multiply these big fractions in the computation thread pool. So let's walk through this. This is kind of cool. So as you can see, what we do is we say essentially for each denominator, we're going to take that denominator and we're going to use it to create a big fraction. So we say big fraction, we give it a random integer, next random integer that comes along, which could be very large. And we take the absolute value of that because we need to be able to have positive numbers. And then we pass the denominator in here, the denominator variable in as a parameter to value of. This will work fine until the denominator's value is 0, in which case we will end up getting an arithmetic exception in that case. We're going to subscribe all these computations to run in the computation thread pool. And then here's where we put the on-error return exception handling operator. And you can see what it's going to do, as we talked about earlier when we showed error handler. It basically checks to see whether or not the exception is an arithmetic exception. And if so, it just converts it back to 0. So we will actually not get an exception thrown here if we get arithmetic exception. It'll just be converted to 0. We log the big fractions, which of course will log the fact that we've got a 0. And then we apply multiplication using the map transforming operator. So you can see that we just multiply each big fraction by S big reduced fraction. So what we get from this will basically be an observable stream of big fractions, one of which will be 0 when the denominator is 0. Now, the last thread that goes through the thread pool here and does the last computation will then be used to do filter on the results that come out of that particular computation. And if you recall, one of those values will be a big fraction that's 0. So we're going to remove any big fractions that are less than or equal to 0. Just get rid of that one altogether. The last thing we do here before we wrap up is we call collect into, which is this combining operator that will convert all the non-zero results, all the non-zero big fractions into an array list. You can see we give it an array list here. We give it essentially a combiner, which is to add each element into the array list. And then the final thing we do is we take the single to an array list that comes back from collect into, and we call flat map completable, which is an operator on single that's going to return a completable that comes back from the results of calling this lambda function. And the lambda function we're going to call here is print list. And you can see what print list does is it's got a little local variable that's a consumer to a list of big fractions. And we convert the list parameter into a single. We use do on success to display the contents of the list. You can see we just iterate through the list and append everything into the string buffer. And then the final thing we do here is we display the string buffer by converting it into a string. And then this particular print list method returns the results of ignore element, which just returns a completable that says ignore the results. So that'll be returned from flat map completable, and that will come back here as the result. And that will be used to synchronize with the async task barrier framework, saying we're done with this asynchronous computation. Now that we've looked at all the code, let's go ahead and run the tests. Keep in mind, we're only interested in the first 2 tests for part 1 of this video. So if you come up here, you can see that test fraction multiplications ended up creating these fraction multiplications. And then we take the results of all these and we sum them up using reduce, and we end up with this final result, which is in reduced form. And it's also in mixed string form as well. Test fraction exceptions, as you can see here, it goes ahead and demonstrates that we got a divide by 0 exception, which of course occurs when we gave a 0 denominator. And you can see here that one of the values is indeed 0. We then filter out that value using filter. And so what finally gets displayed here are just these results minus the one that was 0. You should also note that these computations and the results are performed and printed in background threads, demonstrating that everything is running asynchronously using threads that come out of the computation thread pool. We'll talk about the results of test fraction reduction multiplications when we get to part 2 of the video.